Hi everyone. This is going to be our look at how changing the temperature or the pressure can affect the solubility of a compound in solution. The first thing to say is that solids, liquids, or gases can all dissolve in water. Sometimes we have a tendency to focus on just solids, but it's important to say that any state of matter can dissolve in water. For example, we're all comfortable with the idea that salt dissolves in water or sugar dissolves in water, sucrose. Salts and other solids dissolve in water. Liquids can dissolve in water too. Alcohol, specifically ethanol, is one that can dissolve in water. Um, Ethanol is an alcohol commonly consumed in spirits, in beer, in wine, in vodka or something like that, and that alcohol dissolves in water. Methanol too, other kinds of alcohol will dissolve in water as well. Gases can likewise dissolve in water. Carbon dioxide in carbonated beverages like pop, or oxygen dissolves in water. How do you think fish breathe? The solubility, the amount of solute that will dissolve in a specific volume of water can be affected. That value is not fixed. It does depend on the temperature of the water and, in some cases, the partial pressure of the gas above the solution. The amount of solute that will dissolve in some water is going to be flexible. It's going to depend on the temperature or the pressure. Let's consider each of these three states of matter. We're going to start with liquids because it's easy. The temperature of the water does not affect how much alcohol or some other liquid is going to dissolve in it. Likewise, changing the pressure has no effect. That's an easy one. There's no difference depending on what the temperature is or the pressure to how much liquid will dissolve in some water, one liquid in another. No effect on the solubility. For solids, if we're talking about salt or sugar or something like that, as the temperature of the water goes up, the solubility of the compound also goes up. The amount of solute that will dissolve in the water increases as the temperature of the water increases. Specifically, we're saying a given volume of solute will dissolve more solute as the temperature goes up. A change in pressure, however, has no effect. So, for a liquid, both of those situations had no effect. For a solid, it was just the temperature that made a difference. As the temperature goes up, the solubility goes up. The opposite also happens to be true. As the temperature goes down, the solubility goes down. And there's no change in pressure up or down either way. For a gas, that's the most complicated situation, and we really need to be conscious of the direction of these arrows. As the temperature of the water goes up, the amount of gas that water can hold on to goes down. Because the temperature is up, those molecules have more energy. It makes it easier for the gas to escape the water. And so the solubility of the gas in the water goes down as the temperature of the water goes up. For the pressure, on the other hand, an increase in pressure leads to an increase in solubility. If there's higher pressure above the liquid, it's forcing more molecules down into the water, and we have an increase in solubility. So, as the temperature of the water goes up, the solubility goes down. The solubility of the gas goes down. The opposite also happens to be true. As the temperature goes down, the solubility of the gas goes up. As the partial pressure of the gas above the liquid goes up, the solubility also goes up, and the opposite would also happen to be true. As the pressure goes down, the solubility goes down. If we're talking about the solubility of a liquid, there's no effect either way. Easy. For a solid, we have a direct relationship. Both of those arrows are going up. As the temperature of the water goes up, the solubility goes up. They will both be down as well. For a gas, we have an inverse relationship here between temperature and solubility. As the temperature of the water goes up, the solubility of the gas goes down. As the temperature would go down, the solubility would go up. Those arrows are in an opposite direction there. We do, however, have a direct relationship between the partial pressure of the gas and the solubility of it in some water. As the pressure goes up, the solubility likewise goes up. This is really just a memorizing kind of a topic, but we just have to pay attention to these factors and it'll all be okay. I hope that helps.